magpipis tayo. Yan, sinend ko na sa sa chat yung link. Thank you. Ay, basahin yung instruction na. Okay na ba lahat? Tapos ka na ba, Elizel? Sige. Pwede nang mag-report yung next group. Hello, lovely. Why? Why?
Good evening, guys. Good evening. We are the third reporter, and we will report the second part of rolling stock major parts, assemblies, and sub-assemblies. So, next. Yan. Bago tayo mag-start, mag-icebreaker muna tayo. Next. So, ito yung instructions para sa icebreaker natin. So, guess the number that will be flashed on the screen. The team that answers first after the count of 3 will have 1 point. So, if there's a tiebreaker, one question will be added that is worth 5 points. So, indicate your group number before your answer. So, example, group number 3, underscore 900. So, magsasagot kayo after ng count ng 3 ha. So, next. Ayun na, start na tayo. Icebreaker number 1. 1, 2, 3, go.
₱188 ba yung sagot?
Group 2138.
Ayan, next natin para malaman natin yung sagot. Ang nanalo,
Nauna
group,
group 4.
ayan, ganun lang yung icebreaker. So, next na tayo. Yan. So, 1, 2, 3, go. Ayan, pa-next na para malaman natin. So, yung nauna, tama, sila Gruta, group 5. So, Tig 1 point na yung group ni Hash and ni Gruta. Next. 1, 2, 3, go. Wala pang tamang sagot.
Meron na ata. Group 5
Meron na.
ulit.
Ah, Group 4? Di ba si Bron?
Ano ang sagot?
493? 493, di ba? Si Bron, Group 4.
Ay,
Nice.
Okay, next na tayo. Ayan. 1, 2, 3, go.
meron na, no? Tamang sagot. Group 5? Tama ba? Group 5. Ayan, tamang sagot. 1, 7.
Ayan, next na tayo. 1, 2, 3, go.
Meron na ulit. Group 4. 4 at 5 na.
Arlene, ano yan? Ayan, next na tayo. 1, 2, 3, go. Wala pa rin. Wala pa rin. Okay, magbibigay kami ng clue. Yung una, 6. Unang number, 6. 6. Ala, wala pa rin. Gruta, malapit ka na.
Meron na ata.
Ayan, meron na.
Si
Boron.
Boron. Huh? Wait lang. Anong tamang sagot?
6810. Sila Boron na.
Ayan. Okay,
Next.
group.
Ayan. 1, 2, 3, go.
Group 5 ba una? Paki-check nga. Okay, group 5, okay. Nga lang.
Ayan guys, number 8. 1, 2, 3, go.
Meron na ulit si Eman, group 6.
Parang nauna si Ali. Nauna si Ali.
Kasi
Si
Eri
Ali.
pala. Ay. Group 2. Last na ba to? Sa group 4, 4 points. Sa group 5, 3 points. Tapos group 2, 1 point. Yung scores.
Nanalo na yung group 4. Hindi na lang sa akin mamaya yung GCash number nyo. Thank you.
Hello, naririnig ba?
Rinig.
Okay, okay. So, hello. Let's go na sa report for today's video. We present to you the sequel to the previous report, the rolling stock, major parts, assemblies, and sub-assemblies, part 2. So, this is the overview for today. We'll be talking about first the pneumatic system to the propulsion system. From there, we'll continue to the power system, the primary and auxiliary, until we reach the train management system. Okay, so let's start first with the pneumatic system. I'll be your reporter. Okay, so air is something around us, right? So may abundance of air, pero as humans, we cannot technically manipulate air and use it like how Aang the Avatar or the air nomads have been using it for thousands of years. Pero sa reality natin, hindi siya possible, right? Lo and behold, we actually can. We can, well, we can't, but we can through the use of technology. So I'll take that as a win. Uh, anyway, it's modernized technology is pneumatics. So siya yung pneumatics, yung manipulation of air, so-called manipulation of air. Pneumatic systems are utilized around the globe across industries. It can be utilized sa dental procedures, in neurogastroenterology. It can even play the piano. Yes, there are self-playing pianos na gumagamit ng pneumatic systems. However, sa railway industries, specifically sa trains, ang lawak ng range ng function ng pneumatics. Through pressurized or compressed air, it is utilized in brake control systems and even sa ano natin, yung toilet control systems. So, how about mag-show ako sa inyo ng pneumatics sa modern world before tackling ano yung nasa rolling stock?
Complete lecture.
Uh, So, okay. So, even though na parang chaotic, di ba, ng pagkakagamit. So, even though it is chaotic, it is smart, but chaotic. Pneumatics is utilized sa trains kahit nung mid-1800s pa. Why? Kasi ano, it is easy to maintain. It's safe and reliable. Remember them. Easy to maintain, safe, and reliable. But when it comes to pneumatic systems, even though na magkakaiba ang gumawa at magkakaiba rin ng function, may typical elements na makikita dito like the compressor, air preparation unit, control units, the actuator. Meron pang pathway na a pathway of the prepared air or the compressed air. Let's take a quick glance. So first, yung compressor, it draws in atmosphere and ginagawa niya itong compressed air. Since using the atmospheric air as it is won't work sa pneumatics, unlike with pressurized or compressed air. Next is the air preparation unit. Sa air, there are too many impurities for it to be used as it is. Kasi may mga bagay-bagay like particles na if not filtrated or checked, it would cause more harm to the system rather than skipping on a prep unit just to save a couple of bucks. Then, sa control units naman, sino bang may ayaw magkaroon ng control sa kanilang ginagawa? Not just being able to control the direction of air or yung passage ng air, it is also for safety reasons. Then the actuator which uses the compressed air to do motion. So kino-convert niya yung received air to mechanical energy or yun yung motion. To get the air from the compressor to the actuator, to actually get something done or be in motion, there's the feed line, yung pipe. It is the compressed air's pathway, making it possible to go to desired destinations with the help of the control units. Di siya kasi napakita kanina dun sa collective picture nila. But there are pneumatic systems rin na gumagamit ng reservoir. It stores the compressed air, so it is a storage of some sort. There are train brake systems rin na gumagamit ng reservoir. Pero katulad nga ng nasabi ko kanina, malawak ang gamit ng pneumatic sa tren. Katulad nung may isang company kasi, like according to Parker Pneumatics, marami yung functions, marami yung application ng pneumatics sa trains. Pero ito yung typical na ino-offer nila na ginagamit nila. Yung mga brake control systems, tilting train control systems, automatic coupling systems, yung sa doors, yung uncoupler systems, heating and ventilating, yung toilets, and water control, yung passenger seat controls. So, pneumatics is easy to maintain, safe, and reliable. But for such system to be like that, pneumatics needs a dry air supply, especially for railway pneumatics. So, kailangan niya ng dry air supply. Kasi yung moisture, it is bad. Moisture can wash out grease and cause corrosion. It can lead to ice buildups sa mga low temperatures, which in turn, it can disable the door systems, freeze valves in the brake control unit pa. So the existence of moisture can cause trains being taken out of service too. Yes, it's bad. However, whether we like it or not, the occurrence of moisture is inevitable. Like Thanos, it can just snap the trains out of commission. But is Thanos really inevitable? Is moisture really inevitable in terms of it cannot be mitigated or uh, solved? So most air dryers, gumagamit sila ng granular adsorption medium. It's granulated, so the shock and vibration from all that movement and the operations can cause dust generation, channeling, air bypass, breakdown pa ng granulated bed. There's a significant reduction sa drying performance. And also the shorter service life. It will require more frequent replacement of the adsorption medium. Pero the typical service interval for air dryers is less than 2 years. However, new developments sa drying technology can extend yung service life and reduce maintenance cost while increasing performance. Ang isang example nito ay yung new developments ng Emerson, I mean. So yun yung Emerson Aventix RDD air dryer series. Yan. So yung Emerson Aventix RDD air dryer series or the RDD uses rolled up descant drying technology. The RDD provides a consistent, highly open pore structure through the media, resulting sa superior moisture uptake performance. It is also resistant sa vibration and excessive water loading, making it possible na both horizontal and vertical orientations ay mag-work for more flexibility, installation flexibility, I mean. Another one is that their tech provides a service interval of at least 8 years or greater than 2,500 operating hours instead of the typical 2 years. The RDD, it is a continuous flow design working with 2 columns containing the drying medium where one column is always drying the air and the second one is being regenerated by purge air. So the control valves are constantly switching the air supply between the 2 columns once one column is saturated. Tapos yung isa has to be regenerated. Furthermore, yung high moisture uptake and the improved kinematics reduce the purge loss to less than 15% compared to the conventional air dry technology. So it just means less air consumption and more energy savings. Then sa train operation kasi, need natin to gain greater control and precision para ma-assure natin na it's safe. Kasi safety is the topmost priority. Kahit naman saan siguro yan, safety is the topmost priority. So components must be easy to maintain and have a long life cycle, especially sa control leveling, and brake control, chassis suspension, and pantograph control. Yung technology na need natin kasi dun, kailangan rin niyang extremely reliable and durable enough to withstand environmental conditions sa mga extreme temperature ranges. So, anong tech ba to? So, what tech is it? So, yeah, pneumatics. Pneumatic components are ideal to withstand environmental conditions sa mga extreme temperature ranges for filling a wide range of application sa mga trend. They are intelligent, durable, and low maintenance. Pneumatics is the needed technology. It is the ideal technology, some would say. So the use of air for braking on trains originated pa nga noong mid-1800s. More than 150 years later and more, pneumatics is still the go-to tech for brake control. May relatively new tech na ginagamit for brake control and actuation. Ito yung electro-pneumatic pressure regulator, or let's call it EP. It provides precise control of pressure and flow with dynamic regulation. That's the relative new tech. And the actuation of the integrated valve allows for precision in controls and combines yung dynamics, precision, and yung excellent repeatability with extreme durability. Another example, galing ulit sa Emerson. Yung Emerson EDO5 Rail Series EP pressure regulator. Ito yung nakikita niyo sa screen. That's the EP pressure regulator. So besides braking systems, pneumatics also plays a key role in chassis suspension systems. Again, let's use the example from Emerson. Emerson's customized electronic leveling valve. Ito ay isa sa mga example. It is an electronic leveling valve na nagpo-provide ng significant benefits over dun sa mga manual leveling. Valves primarily consisting of one proportional valve, two switching valves, and a control electronic with sensors. But it significantly decreases the train air consumption and lowers operating cost. So sa pantograph control and actuation, kasi sa electrically powered trains, when it comes to pantograph control and actuation, there's absolutely no room for compromise. Wala. Kasi ang mga pantograph, need nilang mag-function in all conditions at any speed. So merong primary challenge ang mga engineers at mga nagmamanufacture nito. Like, how can it be done? How can we make the pantograph maintain the contact between the catenary cable and the pantograph's carbon strip without pressing against the overhead lines too forcefully? So, bakit naman nila masyado tong pinoproblema? Magkadikit na nga eh. So, kasi if the two components nag-press sila against each other with too much force, masisira lang sila. They will rapidly wear. Pero may iba, nag-rip pa, nasisira. Sayang naman. So pneumatics control solutions provide the dynamic performance na need for this precise application. It is the needed tech to solve that primary challenge. Meron nga yung Emerson, they're partnered with a Swiss company in making pantographs. Kasi it is a primary challenge talaga naman ng mga manufacturers at engineers on how to do it, how to maintain the contact without too much pressure, without too much force. So let's watch this video, short video.
So far in this video, we've shown how we transfer power to the train using a single hanging wire. However, this method is not practical. Sometimes it is not possible to keep the distance between the train and overhead line the same, which means for proper power collection, a height varying mechanism should be used. Pantographs accomplish this task. A modern pantograph looks like this. You can see that based on the pressure of a pneumatic system, the pantograph can adjust its height. If you observe carefully, you can see that during this height adjustment, the current collector remains horizontal. The current collector has to be perfectly horizontal. Otherwise, power transmission will be in trouble. We hope from this animation you can understand why the current collector always remains horizontal. For more details of it, please watch our detailed video about the pantograph. Now, let's see the pantograph in action. The most important aspect for the train after acceleration is stopping. How is this accomplished? You have to apply the pneumatic brakes to stop the train completely. This is a different kind of mechanical brake. Here, the spring force and compressed air forces are acting on the piston in the opposite directions. The interesting thing is that when the driver releases the air from the cylinder, the stretch spring pulls the piston towards the wheel and the brake gets applied. This brake system also provides security in the case of air leakage or broken compressor. The brake gets applied automatically as pressure releases. The pneumatic braking system is fitted under every coach for each wheel pair. So far in this video, we've shown how we transfer power to the train using a single
So let's go to the passenger experience naman. So from the moment passengers enter the train to the moment they exit, merong range ng pneumatic components na nag-ensure na yung experience nila is comfortable and safe as possible. Sa train doors pa lang, meron ng mga rodless pneumatic cylinder that provide reliable actuation. For trains naman na mayroong step para need mo para makasakay, there are sensor control cylinders in the sliding step. The tech provides exact extension and retractions to ensure the step precisely lines up with the platform. After mo makapasok dun sa tren, syempre may mga upuan at sa ibang trains, especially sa ibang bansa, meron rin silang mga toilets pa and other facilities. There are pneumatic components na control and actuate heating, ventilation, and air conditioning systems, the HVAC systems. If naisipan mo naman na need mo jumingle sa CR, meron ring pneumatic components present. An example of this is Emerson's electromagnetic valves na nag-ensure ng proper function ng toilet. But aside from customer satisfaction, meron rin silang very serious function that saves lives. Whenever may makakasalubong na high-speed trains or papasok ng mga tunnels or lalabas ng tunnels, the pneumatic components instantly sinasarado nila yung fresh air intake. Bakit? To help protect passengers from pressure changes. Kasi if hindi agad or hindi properly closed yung fresh air intake, yung pressure waves they can enter passenger cabins. So it is very much dangerous. As usual, for safety and reliability, may mga standards pa rin to meet. Pneumatic components must meet current railway specific standards and requirements, like the EN 50121-3-2 or the electromagnetic compatibility to even its resistance to corrosion. So paano natin mamimit ang standards? Let's take a quick jab sa compression system. Very quick. So when it comes sa standards ng compressed air sa railway systems, maintenance is everything. If yung air compression system ng train is not properly maintained, marami itong consequences. Like unexpected breakdowns, costly repairs, pwede pang in trains natin can get sidelined, being unable to service passengers or even move the rolling stock. So what's the solution? The solution is to stop the contamination of the compressed air through various methods like water separation, filtration, and compressed air desiccation. These are the typical sources of contamination sa air compressors. Una yung atmosphere or the ambient air, which contains impurities. The compressor itself, pero dito kasi sa compressor, it depends kung anong functions ang ginagawa niya. Kasi iba't iba yung pwede niyang panggalingan. Like for example, yung lubricant, the wear particles, or even the coolant. Another source rin yung air receivers at pipes. Kayang ma-retain yung marks ng contaminants that are brought into the compressor from the atmospheric air. Pwede rin niya na yung cooling nang nangyayari ay cause for condensation if the machine isn't drained on a regular basis. As there are different sources of contamination, meron rin different types ng contamination sa air compressors. May airborne dirt, which are too small for the filter to catch. So, meron ring water vapor na if the air is hot, it will retain the vapor, and if the pressure is high or high enough, the air will release naman condensed water. During the latter stages ng compression cycle, yung air is cooled to a more reasonable temperature. So it turns the vapor in the air to water. Then it'll be sent to the condensate drain. So yan yung isa pang type, which is condensed water and aerosols. condensation is not only bad for the internal mechanism ng compressor. Mas makakasira pa ito if the drain is never emptied. So there is also corrosion and pipe scale. Kasi kahit ano namang gawin natin, rust is damaging. Lalo na sa mga ganitong system since moisture is inevitable. It can form on the inner lining as condensation takes its toll within the piping and air receiver. Pwede itong mag-cause ng clog or breakage sa piping or worse, system failure na. Oil is also a type or a state of it since oil is used for cooling, lubrication, and sealing. What dangers the system is the acidic oil vapors. So how can we fight against these different types of contaminations? Meron ditong filters for air compressors. Yun yung moisture, dirt, and oil filters. A water separator filter filters out moisture in systems where air is cooled and liquid impurities. So, Koleskin filters removes oil and water, moisture naman through mechanical filtration. The filter can remove airborne particles as small as 0.01 micron. It also consists of two parts na in order dapat. So, yung first is the general purpose filter na nagpe-prevent ng bulk of contaminations from reaching the second filter, which is the highly efficient filter. Dust removal filters naman, they eliminate the carryover dirt from preceding junctures sa process air compression. It is known to be an alternative to the previous filter. And it also has a roughly 99.9999% success rate at particle elimination. The typical process of filtration is divided naman sa 5. The first 3 is set to remove the 92% of the contaminants from the air. The fourth stage is where the air is dried. Then for the last stage, it is where all dust particles are removed. So sa dami-dami ng standards, sa mga ginawa for the filters, pwede pa rin kasi mag-fail yung pneumatic systems. So if nag-fail ang pneumatic systems ng isang rolling stock, what are the consequences? So if the doors fail, di syempre makakapasok or makakalabas yung mga passengers. Magkakaroon dito ng clusters. May delay sa train schedules, and the importance of door operation is very crucial, lalo na sa mga emergency evacuation scenario. Just imagine it. May emergency pero hindi kayo makalabas or di nyo malabas yung may emergency. If the pantographs fail naman, commuter delays, sudden loss of power, yung train, magsa-stop siya minsan at intersections or sa mga desolate areas pa. If the brakes fail, major incidents will happen. The trains will crash, collide with other structures, loss of passenger life. If nag-fail naman ang suspension system, the rides magiging turbulent siya at di kaaya-aya yung experience. It can also make the ride become more dangerous. Dagdagan pa natin. In the disadvantages of pneumatics, kahit na pneumatics is easy to maintain, safe, and reliable, meron pa rin itong disadvantages. The system is sensitive sa mga changing temps at vibrations, easy to leak. Madali rin magkaroon ng condensation sa systems dito. And if not properly maintained, as I have said earlier, it will cause a lot of consequences. Pero, however, kahit mabigat-bigat ang mga cons nito, the advantages of the advantages of pneumatics is far greater than its disadvantages. Kasi it can be mitigated or solved through manpower. Yun nga, we need to maintain it para hindi natin maramdaman yung consequences. Pneumatics is easy to maintain, safe, and reliable. The source is easily available kasi nga, it's air. You need to compress it nga, pero it's still air. It comes from ambient air, from atmospheric air. Compressed air is not toxic. Di siya nagbibigay ng mga significant risk sa electric shock. It is also not flammable, notably flammable. And if may mag-leak man, hindi siya katulad ng mga toxic substances na if it leaked, it won't negatively affect the outside environment. Before passing the presentation to the next presenter, let me show you a video about how pneumatic systems are implemented through Emerson's COM video.
Robust, reliable, durable equipment, size constraints, temperature ranges, and energy efficiency. These are a few of the hurdles which solutions from Emerson will help you to overcome successfully. From braking to actuators, airflow, and control, all your specifications can be met with Aventix solutions for railway technology. Join us on a journey through the fascinating and challenging world of pneumatic applications in trains. The pantograph connects the overhead catenary cable with a carbon strip and leads electrical power to the high-voltage circuit breaker for further distribution. Pneumatic actuation with a bellow or standard cylinder gives us smooth cushioning. Aventix true proportional valves are replacing fixed pressure precision regulators. Fresh air intake of high-speed trains must be closed within fractions of seconds to limit a pressure wave entering the passenger cabins when trains enter or exit tunnels and in case of oncoming traffic. Toilets as closed systems are using electromagnetic valves to control different functions. Emerson supplies a number of toilet system manufacturers with suitable valves. The origin of pneumatics comes most probably from dynamic brakes on trains. The soft cushioning force of pneumatics is more than 150 years later still the best technology, very simple to maintain and inherently safe. Computer-controlled electro-pneumatic suspension valves enhance the ride comfort. The train manages a plus-minus 2 millimeter height gap between the train floor and platform pre-programmed through GPS. Safe entry for wheelchairs or people with reduced mobility can be assured with a retractable door step, which benefits from the rugged construction of pneumatic actuation. Emerson is supplying air cylinders for the actuation and locking of doors. The RTC TV cylinder with integrated functions for cushioning and emergency exit is possibly a game changer for this application. Strength and robustness gain a competitive edge against electromechanical door actuation. High-speed trains use aerodynamic fronts to reduce air resistance. Nose cones are pneumatically operated and locked with cylinders. Global system suppliers use Aventix valves and cylinders from Emerson. The mechanical coupling to connect one train to another is mostly automatic, without manual interaction. Pneumatics are used for actuation and locking of couplers. World-leading freight car producers require utterly robust and long-life cylinders as well as control valves. These are used to open doors under, on the side, or on the top of freight cars. Since 1969, Emerson is producing composite cylinders, which are self-repairing after a dent from a ballast stone impact. Aventic Solutions from Emerson for railway technology.
That is all for pneumatics.
Ayun. Next naman for rolling stock major parts, assemblies, and sub-assemblies is yung propulsion system natin. Next slide po. Yung ating railway propulsion system is a combination of components such as converters, motors, transformers, and others which provide the tractive force required to propel the train along a specified route within a targeted time. Yung term na tractive force is called tractive effort that is used to describe the pulling or pushing capability of a locomotive. Next slide po. Yung railway propulsion system natin ay kinaklasify depende sa kanyang sources of energy. Una natin is yung steam, particularly steam from water or water vapor, mineral oil products, especially diesel fuel, electricity, tas combination ng itong nasa taas na sources of energy. Unahin natin yung steam. Next slide. Yan. Yung steam locomotives are steam locomotives and steam rail cars dominated the global railway scene for about 150 years. Yung classic railway natin was operated for decades by steam traction. Steam traction is based on energy source water vapor, which is produced in the vehicles by means of a steam boiler. Yung steam boiler natin, nagbo-burn siya ng coal or oil, or less often woods, using a supply of water that is carried with it. This requires considerable heating up time to produce the necessary operating pressure before the train can be started. Ayan, so matagal-tagal bago natin makuha yung steam traction natin kasi iinitin pa yung tubig. Next slide po. Ayan. The core of the steam locomotive is the actual drive system, is the one or more steam engines in which system The actual drive system is the one or more steam engine in which the piston is exposed to pressure from steam on alternative sides and thus finds itself in a continual translative motion, backwards and forwards. Ayan, parang ganyan sa video. Next slide, para mag-gets nyo kung paano yung makuha yung steam traction, papanood ko yung video tungkol doon sa steam locomotives. Next slide po.
Let's learn the working function of steam locomotive engine. The coal is burned on the grate inside the firebox. The hot gases are drawn through long tubes in the boiler to the smoke box, and then out of the locomotive from the chimney. The heat from the firebox heats up the water in the boiler. Water is also heated by the heat from the hot gases going through the long tubes. As water becomes hotter, it turns into saturated steam, which collects above the water. The regulator valve, which is situated in the dome, it controls the passage of the steam to the cylinders. The safety valves on top of the boiler release the steam if the pressure rises to a dangerous level. The saturated steam, which flows through the main steam pipe to the superheater header, and then it travels through superheater element pipes in the boiler, where it is heated up. After that, it will have become superheated steam. The extremely hot steam flows through the steam pipes to the cylinders, where the steam pressure the pistons, which move the wheels of the locomotive.
Ayun, gano'n gumagana yung isang steam locomotive. Pero meron din naman tayong fireless or steam accumulator locomotives. Dito ang kanilang operating pressure are from stationary plant and carry supply steam in a pressure boiler. Bale, wala silang parang firebox doon na ewan. Kasi dinadala sa kanila yung kanilang steam pressure boiler, yan. This means that yung mabilis silang makuha yung steam traction na kailangan para umandar yung steam locomotive. Pero ang disadvantage nito is reduces yung range of activities niya kasi nga hindi siya yung nagge-generate ng kanyang steam. Steam, tama. Next slide po. Yan, konting background tungkol sa steam locomotives. Yung first steam engine natin was built in the 16th century. Maraming important inventions na necessary noong 17th and 18th centuries. Tapos by 1769, Nicholas Joseph Cugnot's steam car, the Fardier à vapeur, was running tests on the streets. Yun. Tingnan mo yung sa babang video. Bali ka pa nag-drive ka niyan, kailangan 2020 yung vision kasi puro usok. Ayun, dahil sa invention ni Cugnot, nag-pave way to sa further inventions. And next slide po. Noong 1803, yung first journey took place on rails in some places with gear, wheels on tracks, and with track on stilts. Yeah. Yung forefather of all steam locomotives as we know them today was the Rocket by Robert Stephenson. Ayan. Cute. Next slide. Ayan. As for the diesel locomotives naman, it uses a mineral oil, particularly diesel fuels, as its source of energy. Meron naman na mga liquid petroleum at gas at petrol engines na ginagamit sa trains, pero ang diesel ang pinaka-useful, yung successful, ganun. Diesel engine and internal combustion machine have achieved the greatest success worldwide. Ayan, kaya diesel fuel ang ginagamit kasi nga pinaka-successful siya. Vehicles with internal combustion engines carry their fuel with them and can therefore be used anywhere. Next slide. Yan. Yung rotation energy produced in the cylinders of a diesel engine can be transferred to the driving axle by three types of transmission. Una is yung diesel mechanical, sunod diesel hydraulic, and yung last is yung diesel electric. Next slide. Ayan. Yung diesel mechanic natin, transfer energy by means of manual gearbox. Ayan. After ma-generate ng rotational energy sa loob ng diesel engine, dadaan ito sa drive shaft into fluid coupling na nagtatransmit ng rotating mechanical power. Tapos papunta sa gearbox, tapos sa wheels na natin. Yung ganitong type of locomotive ay limited sa low-powered and low-speed shunting locomotives. Kaya, hindi niya siguro siya nakikita sa mga in-service, ganon. Next slide. mag-play kagad yung video. Basta sa diesel hydraulic naman, transfer energy by means of hydraulic fluid and torque converters. Ayan. Para mag-gets niyo, watch nyo na lang yung beat. Okay.
The working principle of a torque converter, let's take two fans. One fan is connected to the power source and the other is not connected with the power source. When the first fan connected to the power source starts moving, air from it flows to the second fan, which is stationary. The air from the first fan strikes on the blades of the second fan and it also starts rotating almost at the same speed as the first fan. When the second fan is stopped, it does not stop the first one. The first fan keeps rotating. A torque converter works on the same principle. An impeller or pump acts as the first fan, which is connected to the engine, and a turbine acts as a second fan, which is connected to the transmission system. When the engine runs, it rotates the impeller, and due to the resulting centrifugal force, oil inside the torque converter assembly is directed towards the turbine. As oil hits the turbine blades, the turbine starts rotating. This makes the transmission system rotate and the wheels of the vehicle move. When wheels are stopped by braking, the turbine also stops rotating, but the impeller connected to the engine keeps moving, and this prevents the killing of the engine. A device called the stator is located between the impeller and the turbine. The main function of the stator is to give direction to the returning fluid from the turbine, so that the fluid enters into the impeller in the direction of its rotation. As the fluid enters in the direction of the impeller, it multiplies the torque. So the stator helps in the torque multiplication by changing the direction of the fluid and allows it to enter in the direction of the impeller rotation. The stator can change direction of the fluid by almost up to 90 degrees. It is mounted with a one-way clutch that allows rotation in only one direction and prevents rotation in the opposite direction.
Ayan, next slide po. Yung another type naman ng transmission ng diesel locomotive is yung diesel electric, yung transfer energy by means of electric current. Ayan, alam niyo na yan. So next slide. Ayan, as for the electric locomotives naman, ang magandang characteristics nito is that electric motors can be momentarily heavy overloaded, which meant na it is easy when starting up and also enables the necessary motor size to be kept small. Also, electric drives lang ang may kaya makagawa ng quiet, locally free of emissions, and ecologically acceptable na transport. An example of an electric locomotive is yung LRT2 natin. Next slide. Ayun. In order to get that electric traction, may iba't ibang engines. First off is yung direct current motors or DC voltage. This type of engine is simple, robust, and it is easy to recover energy when braking. Yung problem lang sa DC motor is that yung power transmission niya is subject to losses which reduce the voltage and is not transformable. An example of DC motors ngayon is yung nasa picture. Yung picture nito ay yung running gear at electrical equipment ng Pennsylvania Railroad Class DD1. Di na siya in service and naka-display na lang ang PRR DD1 sa isang museum. Next slide. Next is yung next type of motor natin is yung alternating current motor, single phase AC. Ang advantage naman nitong motor na to is that yung power transmission at high voltage is only subject to small losses, unlike dun sa DC motor natin. Also, yung alternating current natin can easily be transformed. Yung problem niya lang is yung power ng motor is limited. Transformers in vehicles and electronic components make AC current usable for locomotives. Next slide. Last naman ng electric locomotives, electric motors pala, is yung three-phase motors natin, three-phase AC. It is considered to be the ideal traction motor for railways because they can work under AC current and DC current. Ang three-phase motors natin can work in heavy and high-speed traffic. Three-phase asynchronous motors are simple, robust, require little maintenance, and are ideal for recuperation or yung braking current regeneration natin in current systems. Next slide po. So yung process ng three-phase motor natin is yung current natin is transformed inside the vehicle from the input line voltage and moreover in the AC system it is first converted to DC and then always to three-phase AC. Parang yung sa natin diesel electric locomotive kung paano siya yung process. Next slide po. Next naman is yung hybrid locomotives. Ito naman, it uses a combination of sources of energy and in closer consideration. Ang diesel-electric locomotive natin ay fitted sa basic elements netong hybrid locomotive kasi dalawang sources of energy ang ginagamit, diesel and electric. Kagaya nung etong sa gilid, yung Dell 917, Dell ba yan? Dell 917. Kasi nga 'di ba, ang diesel natin ginagawa lang siyang source tapos kino-convert into electric drive. Ayan. Additionally, its special feature is the possibility of being able to store energy and so significantly reduce the total energy required. Next slide. Ayan. Pero ang modern hybrid vehicle has electric traction motors which are always supplied from the batteries. Yung diesel electric locomotive natin walang batteries. So it is not considered as hybrid. Parang lang siya, fitted lang siya sa basic element ng hybrid. So ang batteries natin ay charged by regeneration and the internal combustion engine or fuel cells which run as required and occasionally from the overhead line or inductively. Yung nasa picture, yung ideal na hybrid locomotive is yung from Toshiba. It is clean, environmentally friendly locomotive with reduced exhaust gas, noise, and fuel consumption. It operates as shunting locomotive sa Japan Freight Railway Company. Yun lang po. Thank you.
Andiyan pa ba kayo, guys? Sa hygiene break natin, itutuloy natin yung icebreaker. Then, individual na to, hindi na to by group. Andiyan pa ba kayo? Pa-react na lang pose. Ayan, sige, mag-start na tayo. Next. Ayan, guys, may nakikita ba kayo? Technique nyo dyan, tumingin kayo sa gilid. Paunahan na lang sa chat. I see Jofer. Ayan, 1 point na si Jofer. Connect. Ayan, ang tamang sagot, 668. Next. After ng go ha, pangalawa, 1, 2, 3, go. Nauna sa akin after ng go, nauna sa akin si Ali. After ng go kayo mag-send, guys. Yan, number 3. One, 2, 3, go. Nauna sa akin si Ali. Mali pala yan, guys. 80 lang pala yung nasa unahan. Sorry, hindi ko rin nakita. Ayan, 2 points na si Ali, isa si Jofer. Number 4. 1, 2, 3, go. Nauna sa akin si L. Ayan. So, 4 lang yung tanong dito. Yung huli pang pang tiebreaker kasi. So, ang nanalo si Ali.
So, hello. Yung next naman is yung primary power system. Next. The electric railway needs a power supply that the trains can access at all times. It must be safe, economical, and user-friendly. It can use either DC or AC. So, yung electric railway, from the word itself nga, electric meaning, electricity yung nagpapatakbo sa kanya. Saka, kailangan na yung electricity na to, accessible siya at all times. Tapos, syempre, dapat din yung pinanggagalingan ng electricity, sabi nga dito, di ba? Safe, economical, saka user-friendly. Ibig sabihin, hindi siya ganun ka-expensive. Pero yung quality niya is the best din. Tapos, mas simple gamitin yung DC compare sa may AC. Next. Transmission of power is always along the track by means of an overhead wire or at ground level using an extra third rail laid close to the running rail. So yung electricity, natatransmit siya sa pamamagitan ng overhead wire, yung tinatawag na catenary. And yung third rail naman, kung saan, yun naman yung sa may relay siya nakakabit. And mamaya, mas mapapaliwanag kung ano yung third rail. AC system always use overhead wires. DC can use either an overhead wire or a third rail. So, yung AC traction, lagi na ang gamit niya is yung may pantograph, while yung DC, pwede siyang pantograph or yung third rail. Overhead current collectors use a pantograph. The return circuit is via the running rails back to the substation. The running rails are at earth potential and are connected to the substation. So, in traction power supply system, mahalaga yung pagkakaroon ng return circuit o yung tinatawag na return traction current system, which is yun yung nag-store ng electricity na nagamit pabalik sa substation. Bali parang nare-recycle yung energy. So, next po. A third rail is a method of providing electric power to a railway train through a continuous rigid conductor placed alongside or between the rails of a railway track. Ito yung sinasabi ko kanina na isang way din kung paano nakakapag-produce ng electricity dito sa may railway system. Ipaki-next para mas ano. So, meron ding sliding shoe na tinatawag kung saan siya yung tumatama dun sa rails para mas makapag-produce ng electricity. Hindi ko maalala, parang na-discuss na din to dati. Yung nag-slide, tapos yung kapag na tumama siya, yun yung nakapag-produce ng electricity dun sa may gilid. So, merong tatlong klase ng third rail. So, yung bottom contact, side contact, and top contact. So, yung nasa left side, kung makikita nyo sa picture, yun yung tinatawag na bottom contact kung saan nasa ilalim yung collector shoe. Ito yung tumatama dun sa rails para makapag-produce ng electricity. Tapos sa side contact naman, yan nasa gilid, and sa may top, yung nasa may ibabaw. So, bali kapag top, nasa ilalim yung third rail. Itong tawag dito. Oo, tama. Tapos, sinasabi na yung pinaka-best daw na position is yung bottom contact kasi nako-cover siya sa mga, halimbawa kapag taglamig sa ibang bansa like Europe, na yung hindi siya naaanhan ng snow na napapasukan yung ganun. So, mas safe compare sa may side and top contact. Next po. Next naman is yung pantograph. The pantograph is located on the roof of the train and collects the electricity needed to power the train. It's a common type of current collector. So, yun nga kagaya din nung diniscuss kanina sa yung sa video na pinapanood ni Matt, nakita naman natin kung paano nag-work yung pantograph. Diba? Ito yung nasa bubong siya ng isang tren tapos merong nag-slide siya dun sa may catenary wire na nagpo-produce ng electricity. And next. The electric transmission system for modern electric rail system consists of an upper weight carrying wire known as a catenary from which is suspended a contact wire. So yun nga, kagaya yung sinabi ko kanina, meron siyang wire na kung saan doon nag-slide yung pantograph tapos kapag nagkaroon sila ng contact, yun yung nagpo-produce ng electricity. And ngayon, mas maraming gumagamit ng pantograph as current collector kasi mas mataas yung allowed voltage niya compare sa may third rail. Next. So ito yung overhead catenary systems called catenary from the curve formed by the supporting cable have a complex geometry. So the word catenary daw is the curve that is formed when wire or chain is supported at its end. So bali yung support lang nun is yung end-to-end. So meaning, parang walang ibang post, di ba, dire-diretso lang na nag-slide yung pantograph dun sa may wire. So, sa ngayon, mostly computers yung nagde-design ng catenary dahil nga masyadong complicated yung geometry na meron siya. Kagaya nung sa pinapanood ulit na video ni Matt, kung saan biglang tawag dito, di ba, from pantay tapos lumusot sa ilalim ng parang bridge. So, ganun yung tendency. Kaya parang ngayon, computer na yung nagde-design kasi masyado na siyang complex para sa tao. Tapos ito yung catenary is a system of overhead wires used to supply electricity to a locomotive, streetcar, or light rail vehicle which is equipped with pantograph. So yun nga. Next. So next is AC section. Overhead lines are normally fed in sections like third rail systems, but AC overhead sections are usually much longer. So the subsections can be joined through special high-speed section switches. So yung mga switches na discussion ng ibang reporters na yun yung ginagamit para mapagsama yung dalawang subsection nga. And yung overhead lines naman, para din siyang third rail. Yun nga lang kapag AC system, mas mahaba kasi siya compare sa normal. So overhead lines yung ginagamit. Next po. So next is catenary suspension systems. DC overhead wires are usually thicker and in extreme load cases, double wires are used. Yung overhead wires naman, thicker siya yung na DC, thicker siya compared sa AC kasi kapag mabigat na yung mga loads na dinadala ng tren, parang siguro need na mas doble para mas safe kasi baka may tendency na masira. And yung voltage niya is kapag ka 3,000 pataas, DC na yung main system, but kapag ka overhead yung ginagamit. But kapag naman 1.5 below, third rail, pwede nang gamitin. So next po. It doesn't really matter whether you have AC or DC motors. Nowadays, either can work with an AC or DC supply. You just need to put the right sort of control system between the supply and the motor and it will work. So yung sa AC, mas madali siya matransfer yung electricity sa mga long distance kasi siya yung ideal para sa mga electric railway. While yung DC naman, pang maiksi lang na route, kagaya ng anong urban system saka tramway. So, kahit ano naman, pwede. Basta depende naman dun kung saan nakapwesto yung location ng railway system, nag-vary din kung AC or traction yung gagamitin. So, next. Apart from only requiring a simple control system for the motors, the smaller size of urban operations meant that trains were usually lighter and needed less power. It should be mentioned at this point that corrosion is always a factor to be considered in electric supply systems, particularly DC system. The tendency of return currents to wander away from the running rails into the ground can set up electrolysis with power pipes and similar metallic. So, yun nga, kaya rin DC yung sa urban dahil mas lighter yung railway sila, which means hindi ganun kalakas na electricity yung need. So, okay lang kahit na ano tawag dito na DC direct. Tapos sa DC system, mahalaga din i-consider yung corrosion or other na mga tawag dito. Yun, mga hindi magagandang weathering events or something. Okay na. Okay na, thank you. Next na.
Yeah, next naman yung power system na auxiliary. Next. Ito yung pinaka-picture niya kung ano itsura niya. Then sa next slide, kung saan siya nakikita sa isang train. Saan siya nakalagay. Ayan. Most likely nasa ilalim siya. Yung next slide, ganun din. Ibang picture yung. Ayan. Nasa ilalim siya. Next, sa definition naman tayo ng auxiliary power supply. So, the auxiliary power supply or the static inverter converts the electricity used for interior lighting, displays, air conditioning, and etc. Like yung sa ventilation, pati heating, ganun. Next naman is that it is composed of a battery pack, a low voltage power supply, and a static inverter. Then it is also installed to provide electricity that has low voltage and consistent frequency. Kasama nito yung propulsion inverter kanina. Nagpro-provide naman ng smooth ride comfort. And then, since primary power source, from the word itself, yung pinagkukunan talaga ng power supply, ito namang auxiliary power system, yung nag-act as backup para doon. Delivers energy to the loads as efficient as possible. Kasi itong mga load na tinutukoy dito, it is also managed to avoid wasting energy. And then lastly, it is important that the size and particularly the weight of the auxiliary supply system are managed to contribute to the overall energy efficiency of the train. Next slide. So ito history lang. As the facilities provided on board have increased, auxiliary power has become necessity for trains in order to meet the power required. Electric multiple units were also quick to adopt auxiliary power supplies due to it having onboard electric power. And demands for auxiliary system power have been rising for years as a result of the expanding selection of amenities that are required to meet passenger expectations. Next. For the features naman ng auxiliary power supplies, ito pala yung last na, ito yung unang-unang parang gumamit ng auxiliary power supply. So, ang tawag dito, London Underground Rolling Stock. Next. Ito na yung features ng auxiliary power supply. Ito na sa kaliwa. Una, high reliability, compact, and lightweight. Kasi, although high frequency to, they are reduced. There are reduced pala number of components. Tapos, high efficiency. Efficient kasi single step lang yung pag-convert niya from input to output power. Then, improved maintenance efficiency. Dito hindi na masyado need ng manpower kasi meron ng mga technology na na-invent para mag-self-diagnose na nilalagay dito sa mga auxiliary power supply. Tapos, parallel synchronous operations. Tapos, lastly, yung standby redundant system operation. Meaning dito, kapag redundant, it's more possible to switch systems in case may mga failure. So, pag nasira daw yung train, hindi naman yung train, yung power supply, yung primary power supply, pwede siya agad mag-switch sa auxiliary power supply. And then, yung sa risk naman niya, ito pwede rin siyang maturing na disadvantage. Una, trains may become unsuitable to continue in service or possibly get immobilized if auxiliary supply system fails. Kasi yung trains in a sense, nakadepende siya sa auxiliary power supply. Kahit na parang backup lang siya. Kasi once masira yung primary power system mo, tapos nagkataon sira din yung auxiliary power supply, the train won't be able to operate. Tapos, ayan last, actively maintaining functionality is required if there is loss of an auxiliary converter or other system failure. Ayan. Next naman. Limang pala.
Ayan, so good evening guys. So ako na yung last reporter. Yung report ko is about train control and management system. So pa-next po. So before I start, I will first give a brief introduction about my report. So older railway systems rely heavily on manual operations. For example, merong designated personnel sa kada station o kaya naman sa gilid ng track. Yung mga designated personnel na yon, sila yung nagmo-monitor ng time of arrival and departure ng mga trains na paparating. So, yung mga information na yon, nire-rely nila yon sa train drivers or other train personnels using signals or other manual communications. So, yung ganon, okay naman yung ganon sistema. Kaya lang, of course, kasi nga manual siya, mas prone siya sa human failure or human error. Actually, yung manual operation na yon, nag-exist pa siya dito sa Philippines. Hindi ko lang sure sa LRT and MRT, pero sa PNR, na-experience namin yon nung time na nung time na nag-inspect kami ng obstructions from Tutuban to Alabang and vice versa. Katabi namin noon yung driver, and sa halos kada station, pag dumarating, meron silang tinatawag na hepe. So ayun, may binibigay dun sa driver. So sa papel na yon, nandun yung kung saang station galing, kung saang station papunta, yung time, and also yung mga precautions. For example, sa ganitong specific na place, for example, merong low elevation, ganon. So sa Philippines, ginagamit pa rin yung manual of operation sometimes. Yun. So TCMS are used to manage the train's onboard devices and also the signal devices to prevent collisions with trains in front, and also the wireless devices to communicate with the operation control center. So next. So yung TCMS is the standard control, communication, and train management system for vehicle platforms and applications ranging from trams, metros, high-speed trains, locomotives, etc. So itong TCMS, malaki yung function niya and tulong niya sa tren. Kaya nga to kadalasang tinatawag na brain of the train. So its function is coordinating the control of the different systems that we can see inside the train. So next. Yeah, so TCMS, it provides a single point of control over all train subsystems. So it enables the exchange of information throughout the train using a common network. So madaling salita, nagiging centralized na yung control sa lahat ng mga system sa loob ng tren dahil sa TCMS. So, and also it enables control and monitoring over virtually of any subsystem and function, for instance, doors, brakes, etc. So, TCMS can be used to automate the train subsystems. Nakakatulong to in terms of safety. For example, yung speed, yung brake, yung faults, and also nakakatulong siya in terms sa operation. For example, yung pag-monitor ng energy consumption, system status, and also yung video recording and many more. So TCMS is able to gather data, analyze it, and send logical commands and warnings na nako-convey real-time sa mga train drivers, captains, personnel, and even passengers. Next po. Yan. So yan, makikita nyo dyan yung wayside equipment. Dahil dyan, mas accurate na yung communication during sa operation ng tren, and mas less na rin yung human failure or errors. Next po. So functions of TCMS. First, it provides the visualization of system performance issues and helps train operator and maintenance personnel. So one of the main functions of TCMS is to provide integrated diagnostic on the train. So dahil dito, hindi na manual yung pagtingin sa status ng tren natin, and mas napapabilis at mas accurate na yung ganitong way. So second, it also provides corrective action to be taken to assist drivers. So after ma-diagnose ng TCMS yung system performance issues ng train, nagpo-provide din to ng mga corrective action na dapat or pwedeng gawin ng mga train maintenance personnel or drivers. It also records and monitors performance of equipment and devices located on board the train. So meron akong ipapakitang sa next slide na 12 devices or equipment. So basically, TCMS records the performance of each equipment. And They also give signals to respective maintenance personnel in case na hindi sila nagfa-function ng maayos. Next. So, ito yung sinasabi ko kanina. So, TCMS for the monitoring, control, and automation of number 1, yung HVAC. Ito yung na-discuss last week, heating, ventilation, and air conditioning. So, napaka-importante ng HVAC system sa mga tren natin, especially alam naman natin na mostly siksikan sa tren, no? So, kailangan ng proper ventilation. Ayan, yung number 2, makikita nyo dyan. Makikita dyan yung bearing temperature, speed measurement, lateral vibration, brake instructions. So, yung number 3 naman, yung PIS or PA. PIS stands for Passenger Information System. So, meron ding ganyan dito sa Pilipinas. Ang tawag naman ay Passenger Assist Railway Display System or PARDS. So, ito sa Philippines, ang ginagamit ay LCD screen na naka-install sa loob ng tren natin. So, ang makikita nyo doon ay news, advertisements, current train location. But unfortunately, sabi, parang lagi daw naka-switch off tong parts. And nung chinek ko, nung huli kong sakay sa LRT, naka-switch off nga. And ayun, going back. Number 4, diagnostic. Yan, makikita sa harap ng tren. Number 5, lights. 6, water tank. Number 7, CCTV. 8, batteries. 9, doors. 10, emergency communications. 11, data protection or event recorder. And number 12, train to wayside communications. Next po. Ayan, so punta muna tayo sa components ng TCMS. First, computer control units or CCU. Second, modular input or output. Third, monitor device. Fourth, mobile communications gateways. Fifth, fault data loggers. Next. So, yung computer control unit or CCU, it is a central computer. Since this computer requires high reliability, a software called a real-time OS, which is always processed in a fixed time, is often adapted. So, for example, dito sa CCU, meron kang pinaprocess and hindi siya na-complete within a second. No? It will forcibly reset by a circuit independent of the main processor. So this will prevent freezes. CCUs also offer a wide variety of interface ports such as Ethernet, multifunction vehicle bus or MVP, and serial data interfaces. Next. Modular input or output. So input or output devices provide a flexible combination of digital and analog I/O, allowing future expansion and facilitating a wide variety of control and monitoring solutions. So this unit is located in each vehicle and it is connected to the traction system, braking system, and other equipments to communicate, to monitor status, and also to send commands. Next. Monitor device. So the computer that displays the monitor is controlled by a computer other than the central computer. This is because the screen display has to wait for the user's touch processing, which is incompatible with the real-time OS. So usually, ang size daw ng monitor device is 10 to 14 inch with touch panel function. So yung screen daw dapat bright and yung text daw ay dapat large para hindi maapektuhan in case ng sunlight. And also, yung screen, kailangan ang gamit ay matte with anti-glare, no? Para in case na merong reflection sa likod, hindi maapektuhan yung makikita ng driver. So, kailangan din sa monitor device ng graphical information, pero hindi dapat complex kasi pag masyadong complex yung graphical information, pwedeng mas malaki yung tendency na ma-out of focus yung driver, and alam naman natin na pwedeng mag-cause ng accidents. So, next. Mobile Communication Gateway provides combined GSMP, Wi-Fi, and GPS capabilities, drives down the cost of broad reach telecommunication by using low cost and high bandwidth channels when possible, and makes the train location available to both onboard and remote services. So itong mobile communication gateway, kapag ko-connect to sa Wi-Fi, dapat yung central computer may tendency na magka-virus due to the weakness of the software. So, kailangan ma-secure yung communication network, and dapat yung ma-connect lang dyan ay yung mga equipments or devices na involved. So, next. Yung last naman is fault data logger. So, a data logger or event recorder is a tape recording device fitted within the rolling stock. It is capable of accurately recording certain information relating to the operation and movement of the rolling stock. So, itong data logger, it records the data and movement of the rolling stock during the operations. So, next. So, electronic data loggers record the following information. So, una yung train speed, distance, time, braking, brake pipe, brake cylinder pressure, master controlling setting, kasama dito yung deadman device, vigilance device, and trip gear. And nare-record din niya yung headlight switch operation, horn operation, yung acceleration and deceleration rates, door operation, audio signals, voice communications, status and operation of cab radio system, train control data, both received and transmitted. Nare-record din niya yung time, speed, and position ng rolling stock, and yung cab-based forward-looking video recording. So, maraming nare-record to electronic data loggers. So, next. So, ito na yung last slide. Benefits of TCMS. So, train architecture becomes more efficient. It saves the development and maintenance costs. In TCMS nga, diba? Centralized na yung control. So, mas napapadali na yung train architecture, and nababawasan na yung maintenance and development costs kasi nga centralized na siya. Also, it increases reliability and quicker response times and improvement in punctuality. Since hindi na nga siya manual operation sa iba, no, mas accurate na siya, and mas mabilis na yung communication during operations. So, yun ano. Import. Wait lang, hindi ko pa sure.
Okay na, no? Pwede na tayo mag-screenshot. Open camera tayo.
Mag-send na lang ako ng link dito. Magsisend na lang ako ng link about dun sa questions sa parts. Sige, mag-picture ka.
Open na ba? Wait lang. Game. Game na. Smile. Fine. Thank you.